Hello everyone, welcome to CSE Core Concepts. In the series of data structures, we are talking about the various algorithms to find out the minimum spanning tree. In this video, I am going to discuss about a very interesting algorithm called Dijkstra's algorithm to find out the shortest distance, shortest path for algorithm. Now, this algorithm is useful for solving single source, that is one vertex which is a start vertex, and from that location if you want to find out the shortest path for any types of graphs, maybe a directed or an undirected. This type of algorithms are generally used in real time when you want to find out the routes for delivering the products or vehicles. They are going to reach the destination, so they need to find out the shortest distance. But this algorithm does not work for the graphs having the negative edges. Consider this graph having, this is an undirected graph having weights given on them. Now there are nodes and edges. You can see on the edges we have weights given, and I am considering, let's say, D as my source node. So from this source vertex D, I want to find out the shortest distance from D to each of these nodes. Like if I want to travel from D to A, what is the shortest distance? From D to C, what is the shortest distance, and so on. Okay. So let us, for that, first we will define a distance array, and initially we are going to set the distance of every node as infinite or a very big number. We will assume that the distance is infinite or very big. Okay, but only the distance of the source vertex will be initialized to 0. Just have a look. Distance array is infinite at all positions. We have 7 values here. Okay, so only at D location you can see the value of distance is 0 because D is my source node. So only at D it will be 0. Rest of all the distances will be infinite. Now first I am going to start with the source node, of course D, and we will find out the adjacent nodes of source node D. They are A and E. Now initially I have set the distance of all the vertices as infinite. See, all of them are infinite, right? So, and only D, the one which I have marked with red, understood? The red ones are the one which we have initialized. So D is 0, C, B, F, G are infinite. Right now I have not kept anything for A and E because these are the two nodes which right now I am considering, since they are the adjacent nodes of D. Now we are going to, now infinite is the initial value, but we are going to update with their original weights. What was the original weight of A? 4, and original weight of E was 2, which was given, right? This process is called as relaxing. What we did, initially we set the distance of all the nodes to infinite. Then while processing each node, we are assigning them their original weights. Okay, so assigning the original weights to these nodes is called as relaxing. So we are relaxing A and E by giving them their original nodes. Now you have to find, now 4 is, of course, what was the value of 4? Weight of A? 4. What did I initialize it to? Infinite. So 4 is less than infinite? Yes. So it will be updated to 4, not infinite. Similarly, what about E? E's value I had initialized to infinite. After relaxing, what is its weight? 2. 2 is less than infinite? Yes. So the weight of A will be 4 and E will be 2. Now I will consider D is visited. So I will not go to D now. Next I will go from E. Let us consider the see, two nodes are there, A and E. I have to proceed, right? Which one should I proceed? I will proceed from E. Why? E has the minimum value than A. A has 4, E has 2. So 2 is the minimum. So I will start following this route. Understood? Whichever cost is less, I will follow that route. So let me follow the route with E. Now distance of what are the adjacent nodes of E? Obviously A and C and G. 3 nodes are adjacent to E. A, C and G, right? So for these 3 nodes I have to do relaxing. So what is relaxing? Assigning the original values. So A is 4, fine, C was 3 and G. So distance from D to A via E. So I have, what is my source node? D. I want to reach to A via E because E is the node which I am considering. What will be the total distance? D to E is 2, E to A is 4. So the total distance is 6, right? But the current distance from D to A is what? 4. So 4 is less than 6. Obviously, yes. Then why would I travel from D to E to A? No. Okay. So I will not update the distance of A. It will remain 4. So if I get a lesser distance value, then only I will update. If I am getting a higher value, why should I update? So forget it. I am not going to update it. Let's say the distance from D to C via E. Whatever we will go right now, we will go via E. So D to E is 2, E to C is 4, again 6, right? Now what is the current distance of C? Did I update? No. Current distance was what? Infinite, which we had initialized it to, right? So 6 is less than infinite, yes. So I am going to update the distance of C to 6, right? Now let us go to G. D to E, E to G. D to E is 2 and E to G is 5. So what is the total distance from D to G? 7. What is the initialized distance of G? Infinite. 7 is less than infinite? Yes. So I will update G with 7. I hope you are getting it. Okay, relaxing is what? Relaxing we are doing just to compare whether that value is smaller or infinite is smaller, right? So done. Now next, which one should I proceed? I will be rest B and F are still infinite, right? So next vertex visited will be what? E is done, right? A, C and G. Among A, C and G, which one is having the smallest distance? 4. A, right? So I will visit the other vertices via this smallest distance, that is A. Now what are the neighbors of A? Okay, unvisited neighbor of A is C. E is already visited. E, via E we have seen all the distances, so E is marked as visited. So now there are two neighbors of A, right? D is visited, done. E is visited, done. So now only C is remaining. So obviously we will go via C. So who are the neighbors of C? B and F and G. Understood? B, F and G. Now distance of vertex C via A. Let's go to C first. Okay, via A. D to A, A to C. What is D to A? 4. A to C is what? 3. So 4 plus 3 is 7. 7 is higher than already assigned distance of C. What is the already assigned distance of C? 6. It is no more infinite. Okay. So 6 is less than 7. When I have already been assigned a lesser weight, why should I go for a higher weight? So I will not update. C will remain 6 only. Fine. Now I am going to find out its neighbors. What are the neighbors of C? B, F and G. Okay. Now let us perform the relaxing, get back their weights. Now distance of F, if I want to travel to F via C. Okay, what is it? C is up to C, the distance is what? 6. D to C ka distance is 6. Okay. Now from C to F if I want to go. Okay. C to F will be 6 plus 5, that is 11. Right. So what was the original earlier distance of F? Infinite, if you remember. So infinite, obviously 11 is less than infinite. So I will update F with 11. Distance of B via C. Up to C the distance is 6, right? So 6 to plus 2, 8. 8 is less than infinite? Yes. So I will update B with 8. Distance of G via C. Up to C the distance is what? 6. We need not calculate every time from D to C, C to G. Understood? Up to C the distance is 6. 6 plus 5 is 11. Now if you see earlier in my last iteration, we have already updated G with 7 because G was a neighbor of E. So G's distance is not infinite anymore, right? So let us compare 7 and 11. So 7 was smaller. Why should I go for 11? So I will not go for 11. Okay. So 7 I will not update. Among F, B and G, who is the lowest distance is of what? F, B and G, the lowest is of G, that is 7. So next node which I have to visit is G, and C is marked as visited. Okay, let's go to G. Unvisited node of G, which is the unvisited node of who is the neighbor of G? C and F and E. Among them, E and C are already green, that is they have been visited. So I will go to F only. What is the distance to F? Up to from D to G, the distance is 7. Okay. From G to F, the distance is what? 7 plus 5, 11. Right. So 11. Now, what was in the last one? I updated the value of F, that is 11. Right. So this time it is coming 12. Should I go for an updation? Obviously not, because earlier whatever value has been given, it is already 11. So we need not go for it. Fine. So G has been marked as visited. Next, let us go to F, because that was the only neighbor of G which we processed. Who is the neighbor of F? F has 3 neighbors. See, C, B, G. Among them, C and G are already visited. So only B remains. So distance up to B is what? Up to F it is 10. 10 plus 2 is 8. Okay. So now in the earlier one, what was the value of B? We have assigned 8. Okay, now it is coming 10. Should I update? Obviously not. 8. A smaller one has already been assigned, so I need not assign it. And B is also marked as visited. Understood? So this is how you perform the Dijkstra's algorithm. That is, we initially set all the values to infinite, and then we start from the source node. We go on computing based on the minimum value. We find the neighbors. Among them we compute the values. If it is less than infinite, we will update, or already assigned value, if it is less than that, we will update. If it is greater, we won't update. Okay. So please go through this and practice it. Unless you do it, practice it, you won't be able to understand. So more such informative videos, please don't forget to like, share and subscribe to CSE Core Concepts. In case if you have any doubts or you want me to solve anything else, please feel free to write in the comment section. I will surely try to solve it. Thank you.